Okay, so today, before we get to recursion, we're going to go over test-driven development one more time. Noticed over the weekend, looking at your guys' pull requests, that a lot of you have not done the test-driven, written the test specs in the test cases in Jasmine, or not Jasmine, Jest, or even Python. So we're just going to go over it one more time to just reiterate the importance of it, because come Friday, when you guys get your assessment, you will be graded on the tests you write and whether or not you write tests, and it's a huge factor. So can someone tell me high level, what is test-driven development?
It's finding out the things you expect your program to do before you actually start writing. It's kind of pseudocode, more so like, these are the things I hope to accomplish before I start writing this. So it helps you map out specifics.
Awesome. Yeah, perfect. And then another benefit to just T.D.D. is when you write out those test cases, you kind of have a blueprint of what the overall method is supposed to do. So when you get a challenge, your initial intuition is just go in and start coding. You're not really 100% thinking about initially right away, like what data structure should I use to store some data. But when you write your tests first and you know the expected outcome, at that point you can be like, oh, well, if the expected outcome is X, Y, Z, maybe a dictionary might be useful to implement that to make that test case pass. So right now we're just going to go over again test-driven development in Python with a challenge that you guys already completed. You guys should know we're going to go over factorial one more time, but we're going to do it from a test-driven development standpoint. And we're going to do it.
It's going to be in JavaScript.
It's going to be in Python. So I've already cloned or forked and cloned the factorial challenge. And in almost all the challenges up until this point, you have a spec file already created for you with some test specs, not test specs, but like inputs and the expected output. So you can actually use these to initially start your test-driven development. So can someone, before I even write a line of code, I'm going to do another one. I want to test the expected output type of factorial, okay, given a random value. So can someone tell me what do I need to do to start writing test-driven development? Okay, write unit tests. Well, what's the first thing I need to do?
Import that library.
Import. So unit. Is that it? Sweet. Okay. So, and I'm just going to use these as a reference. I'm not going to use this one just because that one was kind of the one to stump you guys, because it's essentially not possible.
Because it goes into science.
It goes into scientific notation. What's up? So what's the first, like, how do I write a unit test? All right, cool. Awesome. And then within here, let me close this. I'll write unit test. I always feel I'm always doing one. Then in here, I'll be writing my test methods. So the first one, the expected output type of factorial array. What is the expected output type of factorial array? An integer. So what do I need to do with my first test method? So def test returns integer. And then, does everyone remember these?
Yes.
This is just like documentation of like what this test, what the expected output, what this method does, or what this method should return.
So when you call factory,
When- It should return a, let's do number. Okay. So what are some of the built-in methods in unit test? The unit test library. Okay. Self dot assert equal. And as I'm writing these, you can see all these. These are all like these built-in methods that, yeah, almost equals.
Almost equal.
But so I mean, this is a nice like plugin. Hey guys, can you guys listen up? All right, so how do I test the type of that's returned?
Did his int think work?
Let's look it up. How to test type in Python. Type in is.
Type.
What was that?
You just write type.
Perfect. So type, and then factorial. I can pass in any number here because it doesn't matter if it's 1 or 2. I'm just throwing 8. So, comma. Then
number.
So is int. And then down here we have to do this name equals name. Oh, geez. So let's run this. What is that? 3 factorial. So we're in Python. So let's run this factorial spec file. Uh-oh. Let's say. Line 2 and
These are factor functions.
Oh yeah.
ah, cool. So let's just, yeah, let's write print, or let's return print here. Okay, we got one failure. So write a test, then you write run test. So we're gonna go back here, and now we're gonna start typing, or like creating our function to make sure that test passes. So we can literally just like return a number, but ideally we'll want to, let's do like factorial number equals 1. Then we're going to return factorial number. Run that test again. Okay, one test. Did Mike show you that green plugin? So it just like color codes it now. So okay, we've got one that test passed. What did I do? Mo, can you still hear me?
Yes.
All right, cool. So let's write another test that essentially we've got these 2 tests that we want to test right here. So def, move this down. Test returns, you can even say like correct value, returns. Yeah. correct output of, do this,
Would it be reasonable, since we're testing basic, to do one test?
and then put all those down there? You can, but on Friday when you get your assessment, it's not gonna all work within one test. You're gonna get a bunch of expected outputs, a bunch of different kinds. So you're gonna have to write, at least 3 or 4 tests at a minimum. But yeah, I'm just gonna do them separately for all intents and purposes, and just to get in the habit. When invoking factorial 8, let's do, yeah. It should return 40320. And we can kind of copy that, this line, factorial 8, and instead of using type, we're just going to actually invoke that function, factorial function. That should return 40320. So let's go back down here and run it to see if it passes. What happened? Oh, yeah, because it failed, right? Because we haven't actually done anything in our code. So now we can go back to our code and essentially finish the code here, or finish the method. So who remembers factorial?
So
Yeah, so I'm just gonna do quick way,
1.
and then while less than num of factorial num times equals num minus counter, and counter plus plus. Let's test this one more time. I'm gonna clear it. Oh, yeah. JavaScript. Cool. Now, okay, we've essentially written the method. Now we can test this factorial 18. Oh. Let's run it again. 3 tests passed. So that's test-driven development live. And that's kind of how you should go ahead about doing it. But if you're already given all the test cases, like in this case, I mean, you can go ahead and just write the test cases and then kind of comment out the test case, then make sure that one passes, this first one passes, then comment out this one, make sure this one passes, comment out this one, make sure that one passes, and just keep going down the line. Because they're not always just going to be relatively easy, kind of simple, just 1 or 2 test cases. Any questions?
JavaScript.
Yeah.
Just
Yeah, I mean, Jest is essentially, it's just takes a little bit more time to set up. Mo, do you have any questions?
So the import statement on +9.
Mm-hmm. This import.
Guys come back to it.
Yeah, so the question was, is this import unit test mandatory for writing test specs in Python? Specifically with this library and this format, yes, it is necessary. You need to import unit test because when you import unit test, you get access to these s or equals methods. So if you go back,
Really, what it looks like what you're doing is you're making a new class that's a subclass of unit test class.
you can think of it like that. But like we saw this yesterday, class which is an object. So essentially, you're just making a testing class called factorial test case, which is testing object specifically to test the factorial.
So like step 9, go from factorial and factorial.
This one.
Yeah. So you what's in the class.
So what am I doing here?
Yeah.
So from the factorial file, I'm importing the factorial function. So if I were to call this factorial Python, I'd have to call this factorial Python. And then I'd have to chain. Does that answer your question? Awesome.
This is like the Python version of export dot in JS.
Correct. Yes.
The last one you said you had if. What was that? No, like down the bottom of your spec.
Oh.
What's the purpose of this?
I'm actually not 100% sure what this purpose is.
Okay.
It's somewhere, and if you look at the unit test documentation, it'll probably tell you to require this because if under,
So I would make that a practice.
yeah.
Got it. Okay. That didn't seem like it's just like,
And this, yeah, it's imperative to know how to do test-driven development and write unit tests. So every single position, engineering position you will be in, you'll be writing unit tests, whether it's actually test-driven development or just writing your code and then writing test cases based off of your code.
It sounds like what you just, so writing your code and then writing tests based off of your code is different than what you just saw, right?
Right. This is test-driven development. You're writing your test cases first, and then based off of the expected output of those test cases, you're determining what your method should look like. And it's good to do that because when you write your test cases, you have a bunch of them, you can kind of go down the line, make one work, and then, yeah. Also, if you kind of already know what the expected output is supposed to look like, you can start architecting what data types you should be using in your method or your function, like from the start. Because I've seen a lot of people, not a lot of people, but people adding additional requirements to challenges that aren't necessary.
the scope creep thing you're talking about this thing? Yeah, that's-
Yeah. So if you already have the test cases written, all you have to do is make those test cases pass. You don't have to do anything else. Your function or your method doesn't have to do necessarily anything else.
Essentially, this testing is probably how we might write our code anyway, when we're setting it up to referencing and testing.
So basically, you do your
Running our code to figure out if it works.
Yeah.
So that way we can go to test and see how it works.
Right.
Makes sense.
So
basically you do your pseudocode. You kind of pick like little milestones. Like once I get to this point, I should be able to test this correctly.
Yeah.
Pretty much just test until you're done.
and I'm not 100% sure how the grading rubric will go for the assessments, but it could possibly be if all your unit tests aren't passing, then you might fail. If you haven't covered all the unit tests.
And to go to that question. All right, so I understand. It looks to me like the last two tests are simply testing the same thing, which should, if you don't mind, it seems like they're unessential unless there's something different, like when we do the parentheses. When you test parentheses, if you did do something, of course, it'll pass all these, but not that last one. How do we know the capacity, what we're supposed to go with our test for that grading? So here, you have first test says, okay, we have an integer being sent back, which we don't actually have a factorial done. Second one shows a factorial is done. Is a third one considered, if you said like 3 to 4 tests, just because we make a third or fourth test that maybe testing the second one just in a different way? Is that if there's nothing changed, to really come out with a different out there, any actions that accepted as a test, or is
It could be
rated on how we tested it in that fashion?
You're supposed to test all your edge cases, or as many edge cases as
Oh, we have edge cases.
Yeah. So so this is a relatively straightforward one. There's just it returns a number. And it should be the correct number. If it returns like a string, if it returns a human sentence, and depending on your input will determine how that human sentence is concatenated. There can be many variations of that. So you're going to have more than essentially 2 test cases here.
Because we know what we're looking at when our test is. We just have to write the test and have it work. Yeah. Okay.
But in the future, in the real world, you don't know those test cases. You have to develop those first.
That's where the kind of the scope creep, not necessarily scope creep, but kind of sensing every possible thing that can go wrong is where your mind needs to be developing the test. So user inputs something that's not a string, you gotta test for that. Yeah. And those are edge cases, right?
Yeah, those are edge cases. And you're not going to cover, and when you're actually in the real world and you're writing functions and classes, 99% of it, you're not going to be able to cover every single test case. There's no software that's 100% foolproof and 100% test coverage. That's what they call it. But to get majority of it to where majority of the user experience will fall into this realm of which you're testing. And then there's outliers that are just inevitable that can happen.
So beta testing comes in to kind of on that.
So yesterday with Boggle, it was asking for strings, you can input any kind of string. So I imagine something like that, you could probably have 15 different tests that you need to run through. What if they didn't put in the quotes? What if they didn't put in you? Whereas this one, you only think of 2, but I imagine our assessment might be a little bit more robust than answering with a number.
Correct. And right now we're just with factorial, we're only testing a method. We're not testing a class. So if this was a class, or if we wanted to import a class, we'd actually have to set up an instance within the test case. So for Boggle, we always do new game equals Boggle. I don't even know what it was.
BoggleBoard, yeah.
So now you'll have access to this new game instance, and now you can test all the methods within BoggleBoard in here by calling new game dot shake.
Okay. So you're testing it method by method in the class object for during that instance, right?
A method by a method.
Yeah, because dot shake is a method within BoggleBoard.
Right. Okay. Yeah. And then you can test if this is an object, because if you ever, we'll get to when we get to BoggleBoard. We'll just discuss a little bit more about that. Any other questions? What other questions do you have? Yep.
It's not really a question per se, but I really had a difficult time. I did get it to work eventually, but I had a difficult time getting the test to work. So if you could show me some sort of foolproof way to make the jest to work.
Jest to work?
Yeah.
Okay.
So I tried downloading it, making the JSON file, and stuff like that, and there's just so many cases where I can't get it to work.
So it's my recommendation to utilize Python in the assessment.
I agree.
Okay.
That sounds great.
As long as it's an option, right? It is.
I think it's an option. But we'll cover Jest later on, a little more in depth. Because we're not Jest is just one testing library. We're going to be using Jasmine. We're going to be using, I don't even know if we're using Mocha. We're definitely probably going to be using Enzyme with Jest or Mocha. So I wouldn't get focused on just Jest at the moment. But
So don't worry about it too much.
yeah. But if you want assistance setting it up, I'll walk it through you.
Okay. All right.
There's an option. That's the best intent.
Okay. So if nobody has any other questions, let's walk through BoggleBoard. And we're not gonna solve the entire thing. We're gonna do curriculum. We're gonna do steps 1 through smart 3.
You got Sebastian got you through, right? That's
Yeah,
nice.
through to the
Yeah.
final. You
Yeah.
explained the
Yeah.
rest of it. You didn't just tell me.
So can someone tell me what a class is? Or what like object-oriented programming is? And why do we use it?
Like basically setting up a template that you can run different instances. So there's some things that you need to access multiple times over and over and over again, and it's just a faster way to do it.
And it's also associating the functions or the method that you're executing with the object on which they're being executed.
Correct, yes. And why do we use instance variables like self.new board equals instead of like class variables?
Because you can use them throughout the entire class. Each one of those functions, they can be accessed throughout.
So that when you make changes to it, it doesn't change all the actual template, it'll actually just change.
Class variables are unchanging. And then the ones inside the instance are the ones that are available.
Class variables themselves are not necessarily when you mutate them, you mutate them for all other instances of the class later reference.
Right. So yeah, I mean, pretty much everyone said something that was correct. You guys all collectively got the right answer. So I'm just going to give an example of what an instance is. So we have Juliett Platoon game equals BoggleBoard. And then we have, so this is an instance, this object, this class object creates an instance of Juliett Platoon's game, if I said that right. So the reason why we do use class objects is because multiple people can be playing Boggle around the world. So we have Juliett Platoon game, and we can do like another game equals BoggleBoard. And that's one reason why we don't create class variables like new board, is because if we change this new board for the Juliett Platoon, it will also change another game's board. So that's why we have to initialize a new board.
It might be good for something like we need to have a reference list of all letters.
Yeah. So if yeah, exactly. So if all the dice in a game won't change ever, we can create like a class variable.
Oh.
So let's move back to Boggle. So our goal is to just create a basic BoggleBoard that looks something like a 4x4 matrix. Let's go ahead and do that. So game board. And I just want to set up that grid. Just to like, that's the first thing I want to set up is a grid, a 4x4 grid. You know, we can do that. I just want to print the board just to see. Or let's do def view game board. And I'm using this, why am I using this self keyword Why am I passing the self within this method?
You want to give access to all the contents of the instance.
All right, correct. So I'm passing the self keyword so I can give access to all the instance variables within this method for that specific instance.
You need to do quote.
What am I doing?
You got a semicolon.
Yeah, semicolon after
Oh.
self.
Thank you. So let's print self.game. And how do I invoke view game board method?
You actually have to go into the shell.
Well, you said Juliett underscore Platoon underscore game dot view underscore game underscore board. So that's where you're connected into that function.
I'm invoking that. So let's,
The test on that.
I'm going to run this just to see what that game board looks like. Hopefully there's no errors. Let's do this.
Is it okay to turn on the lights procedure so we can-
Oh yes, you guys can turn on the lights. And also,
Thank you.
if you want, where are the settings? Never mind.
Code.
Is it Python? BoggleBoard.
Juliett,
Expected. Oh. That might have been it. Okay, cool. I've got 16 game boards, or 16 slots that I can create a 4x4 matrix with. So I'm going to do a print board. Method. And there's multiple ways. I've seen a bunch of multiple ways that people did this, but it's okay that we have the board that looks like this up here, like it's just an array of strings, or it can be an array of arrays, whatever. But we want to just to print it to look something like this. So I'm going to do for I in range 0, comma, length, board. Now, the game board or length actually takes in, well, let's do 4. And then, so this range, or I'm sorry, yeah, range actually has the optional to take, or has the option to take in a third parameter, which is a stepping. It's like every 4, grab the index. So I'm just going to print I. Oh. All right, but I'm going to show you what index it prints. Change this. One, 4, 8, 12. So every 4th, it's going to print the index.
What did you say 1 for?
I'm sorry?
You said 1 for.
Oh, I'm sorry, 0, 4, 8, 12. These are the index. So with that, I'm going to print. Does anybody know what the join method does?
Yeah, it turns the arrays to. Can.
So if I do chat join self.game I, then I do want to do I. So right now, for the first I, it's going to the first index. And I want to print index 0 to 3. But so if that was the case,
Oh, I plus 4.
there we go.
That's slicing, right? That's called slicing. That thing at the end of the game board.
Oh.
Oh yeah, that's a big bracket.
There we go. Invalid syntax. This should work. Cool. So there we go. And now if I want a space, I just add a space there.
This is so
So there. We got our initial game board set up. So now shake. Shake's really fun. So if we look at the requirements, where'd they go? We want to print random letters. I want to see if Juliett Platoon's good. And put them in those indexes.
Okay.
So in the first part, you could have just grabbed a random letter in the alphabet and kind of put them in there. But we want to do the smart BoggleBoard, in which we already have predefined dice. So we can even copy paste these dice. So there's a dice. I'm going to create an array.
Would that be a good case when you a good idea to do that a class array?
You can. But what if one game loses their dice? Or loses a die? I know that's never going to happen, but like, it's going to take a while.
What hotkey is that?
Is there a hotkey?
Oh, where you should
Just highlighting.
You can do Command Shift and then
Command Shift.
Command Shift and then drag your mouse down. But you gotta hold Command Shift and then drag your cursor down.
Drag.
You can highlight all of them at once. But it'll also be
Also, the commas.
Yeah, I don't want
No. I was doing it all day yesterday.
Oh, hold on. Actually, I'm just going to copy.
This is one of what's his name? Sebastian was showing.
Yeah.
Well, I just copied from. I'm looking at a reference.
What key were you doing to make the thing straight?
Oh, so if you highlight,
yeah,
and just make it a string, like just click the string.
Oh, okay.
Sorry.
Makes sense.
All right. Oh. So now we're down here at the shake.
Mm-hmm.
So how do I randomize? So I want to show. So these are dice in an array. Is there a method that I can use that randomizes this array?
To import the random library.
What is that?
You have to import the random library and then use the random.shuffle.
Cool. So yes. So there's this library called random. Python random. Do they have a bunch of range? Do I have shuffle in here? So right here, we have this random.shuffle. Shuffle the sequence in place. There. So let's, initially I just want to shuffle the dice. So random.
Shake mode.
Let's print the dice. I want to print. See if this even works. I don't want to print the board anymore. I want to shake it. Shake. So the first one we have AAEG. The second one we have DISTY. And if we shake it again, it's always going to be different. So with that, we've shuffled our dice. And now we can essentially randomize or enumerate over each element or index in the array of dice, and then pick a random number between 0 and 5, index 0 and 5, and then grab that letter and then push it into like the game board at a specific index. So how do I loop through an array including the index?
For a variable, comma.
You can say like variable die.
Variable die in dice.
So you can say for die in dice. You're trying to say.
I want to get the index.
For index, comma, and then.
But you want to get.
Yes, they.
So there's this enumerate method. Let's do geeks for geeks. Geeks for geeks is good. See if it has anything. No. Doesn't really say, but
Yeah, it does include the function.
yeah. Now let's print I just to show. What did I just do? So yeah, I've got all the indexes of I. So now I want to roll that individual die and have it land on a specific letter within here. Yep.
Tom, could you potentially do a for I in length?
For I in length.
Yeah, for I in length of GameSoft.GameBoard.
Are you talking about for in place of enumerate?
Yeah.
Oh yes, you can.
Okay.
Yep.
Question also, do you need to do two variables, or do you just care just before I enumerate? You're going to be placing it in self.
Let's see what I looks like if I do that. I think you might need the space. Yeah.
So you get okay.
Yeah. So you'll need the space.
When you do enumerate, it returns a 2.
Yeah. And a lot of people will do that just to ensure, like, as a notificator to let other developers know that that underscore space is not used anywhere else. But go here. So right now I'm at the index of each die. Now I want to grab a random letter within that die. It's like I'm rolling an individual die and have it land on it. So how do I generate a random number for the roll? I'm going to roll a die.
Rand int. Instead of 0 to 5.
Cool. I'm going to copy that. Now I'm going to print just a roll. Like what did I roll? A 5, 1, 5. So those are the index. That's the index of the individual die I'm rolling. Now I want to grab that letter in that die. So I got to grab that letter. How do I grab that letter?
The game board.
Would be the, I want to just grab the letter. So I'm grabbing that index 1 or index of 0, sorry, right here, and then cool. Now let's print that. See what letter looks like. See if we're on the right track. Cool. We got all these different letters. But now, if we look back at the requirements, we're still only going to have one core shake, BoggleBoard. The following is a list of boggle dice with Q representing as QU. So how do we deal with the QU? So we have to replace, anytime it lands on a Q, I know where it's at, right here. It's a change it. I'm sorry?
In this statement?
Perfect. If letter equals Q, the new letter will equal QU.
Is this necessarily the best place to do that, or would it be better to just do that in the board function?
That's what we did basically on QU. Was there was 2 boards. There was one that we're actually using to make the check, and then we actually had one that you would actually print to see. So the one that we would actually use to check whether or not the word was there, we would just use the
My
Q.
thought process on this would be, if we're putting it here, then when we print it, we're going to have to also check to see if the Q, so we adjust the spacing.
I mean, I don't know if the spacing is like 100%. It doesn't have to be like everything evenly spaced 100% of the time. So we'll see here. So now I want to insert these letters in the game board. So there's 16 spaces. There's for 16 dice, right?
Mm-hmm.
So all I kind of really have to do is game board at the index I. So I'm gonna uncomment that out. Game shake. Now I'm gonna just move this print game board. Oh geez, there we go. Let's see what comes out. Like that. Let's see if we can get a Q. There we go. It's a little off, but the game board still prints for it. Any questions? What questions do you have? I know I've seen a lot of people do a bunch of different ways. There's plenty of different ways to do this. Like the first time I did it, I made it an array of arrays. Only so when I'm looking for a letter, it's kind of easier to use indexes, but plenty of ways to do that. I've recorded the video, so you guys can always reference it. So if you guys don't have any questions, I'm going to stop the recording. You guys can take a 10-minute break, then we're going to come back and talk about recursion in the call stack. Yeah. Yeah.